Hi everyone, thank you for joining. My name is Maud. I'm a developer relations engineer for web privacy and security at Chrome. And today I'll tell you about our favorite haunted house, the web, and Chrome's vision for post-Spectre web development. So what does that mean? So when I was preparing this talk, I was looking at a mental image, a way to talk about Spectre and what it means for the web. And what I ended up choosing is this image of a haunted house. On the 3rd January of 2018, the world learned about Spectre, an exploitation of hardware vulnerabilities. And it's not an ordinary one, because not only is it very serious, because it breaks the isolation between applications, meaning that an attacker can read your application data, but on top of that, it makes most devices vulnerable. And it's hard to fix, because it's baked into hardware. And well, a Spectre is a ghost, so as long as it's here with us, it's a little bit like if our house was haunted. Spectre forced us to rethink the way we understood our place, the web, and the way we build secure sites. So what are we going to talk about today? First, we'll look at how the Spectre story started. Then I'll tell you about how browsers can help mitigate Spectre-like attacks. But we'll quickly see that it's not enough. So we'll move on to what we as web developers can do to protect our sites. So that part 3 really is key for us. And finally, we'll take a peek at what's next. So how Chrome sees the future of post-Spectre web development. Now, let me clarify one thing. When we talk about protecting web users from vulnerabilities, 2 aspects come in. And one is the protections that browsers as products decide to apply. And I will talk about Chrome's approach. But browser-specific approaches only protect the users for that specific browser, so they're not enough. And the second aspect we'll talk about is the protections you can apply as a developer to your site. And these are HTTP headers that are supported across multiple browsers, so they're web standards. And I won't just tell you about best practices, I'll also try to share concrete tips and tools that can help you adopt these features. And when I do, I will signal this on the slides with a how-to or a tool sign, so watch out for these. And before we start, let me give a quick shout out and credit to all my colleagues whose ideas, articles, and work and demos are featured in this talk. Right. Now, we're all set, and let's dive in. How did this all begin? Imagine your typical web application. It may load external fonts or styles or scripts, or it may embed resources like images from third-party servers, or it may embed iframes like maybe a map, or maybe it embed videos, social media posts, and so on. And it can also probably open windows to another web application. So the web is inherently composable. And as web developers, we often take that property of the web for granted, but we use it all the time without necessarily thinking about it. And this gives us a lot of freedom, and it's key to help us build powerful websites. But there's one rule. There's one key fundamental rule of web security, and it's called the same origin policy. And what it does is it keeps an origin independent from another while still allowing a certain extent of interactions. So I will explain, but first let's pause here for a second and think about what we mean with the term origin. So what an origin is it's a combination of a scheme, HTTPS is a good one, and a host name as well as a port. So here's what the same origin policy says. You can read data in your own origin from cat.example to cat.example, but you cannot read cross-origin data. So the same origin policy means that by default, you can't read data from dog.example, unless dog.example uses cross-origin resource sharing, CORS, to explicitly allow other origins to read the data it hosts. So for example, an image CDN may opt into CORS and allow cat.example to read the data of the images it hosts. And now you may be thinking, but wait, I load images and scripts from other origins all the time. So yes, let's look into this. Imagine your site is cat.example. Take an image from dog.example, so another origin. You can embed an image from dot.example on your page, and users visiting your sites will see it. But what you cannot do is read the data, the raw data, the bytes of this image. The same origin policy forbids it because this image is loaded cross-origin. So, for example, loading a cross-origin image into a canvas element using JavaScript will be blocked. And maybe you've encountered this before. And this behavior, by the way, is called an opaque response. Now, let's look at another way same origin policy manifests itself with iframes. So by default, you can embed a cross-origin iframe, but due to the same origin policy, you're not allowed to read its content. For example, if you're trying to use JavaScript to access a document in that iframe, that will be blocked. So great, the same origin policy disallows some direct access to data from another origin. And while it does give you some protection, it still leaves room for many types of web attacks. So remember how we said that the web is composable and it gives us web developers a lot of freedom? Well, it also gives attackers a lot of freedom, so a lot of options to try and exploit web vulnerabilities. So let's see. By default, any site can embed your resources, so your images, scripts, and other resources, styles. Or by default, a site can also directly just embed your site, your origin, as an iframe. Or it can also make a GET or a POST request to any endpoint in your application. And it can also open your application in a new window. And all of these capabilities generate a number of vulnerabilities. And we don't need to dig deep into each type of attack, but the point is that all of these vulnerabilities have one thing in common. All of them are due to a lack of isolation in the web by default. And here by isolation, we mean isolating origins from each other when they're open in a user's browser. And in case all of that was not enough, we have like an invited guest in the house that just made everything worse. And this is Spectre. You can see Spectre in action today in your browser. So if you're curious, try out this demo. This demo uses Chrome to demonstrate the attack, but these issues are not specific to Chrome. So you can expect that other modern browsers would be just as vulnerable. And this is quite scary because it shows that Spectre exploits against JavaScript engines is doable. So Spectre gives malicious actors one more way to execute attacks and access data in your application that they really shouldn't be able to. Right. That sounds pretty bad. So are we doomed? Then what can we do about that? Well, browsers, for one, should be able to help because they're called user agents. So they should be able to help protect users from these attacks, right? So let's, in this section, take a look at what browsers do. First, what browsers can do is to make attacks harder. In order to perform a web attack, a Spectre attack, an attacker needs to measure how long it takes to read a certain value from memory. And in order to do that, they need a reliable and accurate timer. So one thing Chrome and other browsers have done is to reduce timer resolution. So this helps. And on top of that, there are a few advanced features that can be used to construct a high-resolution timer. And one example of that is shared array buffer. So usage of that feature is restricted to sites that have opted into a specific secure state, and I'll come back to that. So these mitigations help, but even so, attacks, Spectre attacks, and other web isolation attacks we've seen are still possible. So the second thing browsers can do to reduce risks in case an attack occurs is to make sure that there is no data worth stealing. So how do we make sure no data is worth stealing at the process level? Well, in 2018, Chrome has added site isolation. And this was a major change to the way Chrome works. And what this means is that with site isolation, each process contains documents from at most one site. So iframes embedded in a page or pop-ups that are opened by a page end up in different processes. So even if a Spectre attack occurs from evil that example, data from other websites like cat that example would not be loaded in the same process. So there would be much less data available to the attacker. And this significantly reduces the threat that's posed by Spectre. And Firefox also implements site isolation, and it's called Project Fission in Firefox. So site isolation is great, but the thing is that it's not a web platform feature. It's a browser architecture choice. So not all browsers choose to implement site isolation. Safari doesn't have site isolation, for example. And even for browsers like Chrome, who choose to implement this approach, it still causes performance overhead. So for example, Chrome uses site isolation on desktop, but on Android, it's much harder because of the memory constraints. And Chrome on lower-end devices, for example, may never have site isolation. This means that site isolation is not a silver bullet. So what else could browsers do? Well, one approach, as I mentioned, is to make sure there's no data worth stealing. And an empty house is just not interesting to haunt, right? Well, valuable data usually comes from logged-in users, from requests that have been sent with cookies. Luckily, since 2020, browsers have set up a secure default behavior for cookies. And this is done via the same site attribute, which has no value of lax by default. What this means is that evil that example can still load cross-origin resources from your site, cat that example, but these requests will be sent without cookies. So this makes the responses of very little value to an attacker. But still, same-site cookies have some gaps because they miss the flexibility to allow some resources to be requested across origins. As soon as you need to allow some resources to be requested across origins with a cookie, same-site lax is already too strict. So you need to use the least strict option, which is same-site none. And there are large sites that do need to set or that do set same-site none because they have endpoints which would break otherwise. And with same-site none, your cookie will be sent in response to cross-origin requests, including requests from an attacker. So evil that example. So yes, browsers do help with architecture choices or good defaults, but Spectre and other isolation bypasses are still possible, and the house is still haunted. Now, buckle up, because this is the part where we'll talk about what you can do and look at some actual code. So we web developers, we shouldn't need to understand Spectre in detail in order to protect our applications, right? And in fact, isolation issues in general are not new. There are traditional web isolation vulnerabilities that have introduced CSRF, XSSI, clickjacking, and all of the others. These have existed for a long time. And luckily, there are some opt-in security features that we can deploy in our web applications that can protect our users from both these traditional web isolation issues and also from Spectre and Spectre-like vulnerabilities. So this is good news, and all of these features can be turned on via HTTP headers. So before we dive in and look at all of these security features, you may be wondering if you have to use all of these features in all your sites and applications. So the short answer is you don't need to. you probably don't need to protect your personal blog with all of the features we'll talk about, even though it's a good way to try out these features. But you should use these features for web applications people log into in order to access sensitive data. And now I'm leaving it to you to define what qualifies as sensitive data for your users. But in general, as a rule of thumb, when you have login functionality, you're likely to have sensitive data. All right, so we've been setting the context. Now let's start with the to-do number one for you, the best practice number one. Isolate your resources, images, scripts, and so on. Why? Because it shouldn't be possible for a cross-region site you don't trust to embed an image, document peer review, or load a script from your site. So you can think of this to-do as locking the door of your house and only let trusted people access your stuff, your resources. And one way to do that would be to look at who's knocking at the door and screen them, right? A little bit like a doorman would do. Well, the web platform has a built-in doorman, which is fetch metadata request headers, except that doorman only asks question and it gives you, the homeowner, the developer, information about that incoming request. And in turn, you decide what to do with that request. So here's how it works. On every HTTPS request, browsers send several headers that give your server security relevant metadata about that request. So we have a Snyk fetch site that tells you if the request comes from another origin, Snyk fetch mode that tells you if it's a sub-resource request, and Snyk fetch test, which tells you how the response will be used. And another one, you can check the article here on the slide for details. Then you can use this data to decide whether you want to accept the request and return a response, or if you want to reject it. So let me show you a quick example of what middleware could look like here with using these headers. So first of all, you would allow requests without the header in order to be backward compatible. You could then decide to allow requests that are sent by your own application. And if you want to, you can also decide to allow cross-origin navigations. So this is one simple example of how you could use fetch metadata, and you could do much more. But still, the idea is that these headers help you implement robust security logics on your server. But as you can see, they do require some logics for you to write, and they do require some effort to deploy. So there's another thing you can do in order to protect your resources, still as part of this to-do number one, which is to set a cross-origin resource policy header, so CORP for short. And so that one is not a request header that you'd examine, but instead it's a response header that you would set on your responses, images, scripts, style sheets. And what it does is that it controls which origins are allowed to embed a given resource. So what you can do is set a value of same origin for resources that should only be used by your origin. And if you set same origin for a given script on your site, get that example. In case evil.example tries to load that resource, here's what will happen. The browser will block loading the resource even after the response is received. So evil.example is stuck. Now, you don't need to be overly restrictive. So if you have static resources, for example, they contain the same data no matter who requests them. They're static. So they cannot contain interesting information that an attacker couldn't obtain otherwise by other means. And it can be valuable for embedders, sites that are trying to embed your resource, to be able to debug. So in that case, you can set the value of the CORP header to cross-origin. And this will allow these static resources to be loaded across origins. So we've talked about Snyk fetch headers and cross-origin resource policy, plus the fact that your authenticated resources are by default protected by Snyk lax unless you decide to do otherwise. Still, it may be tricky to make sure you've isolated all of your resources in order to complete this to-do number one. So there's a tool that can help you check what you've missed, and it's called Spectroscope. It's a Chrome extension. And a great way to familiarize yourself with the Spectroscope extension is that Spectroscope demo, so you check it out. Now, that was to-do number one. You know what to do to protect your resources. So we can move on to our next best practice in order to mitigate isolation issues in your application. And this is the second to-do. Isolate your windows and frames. Why? Because it shouldn't be possible for an attacker to open your site as a pop-up or to just embed it as an iframe. So first, let's look at how you can isolate your windows. You may already be familiar with rel no opener. With that attribute, you can a link can be opened from your page, but it will get no access to your window. But this attribute is only going to affect navigations. So instead, you can use a header that gives you more control, and this is the cross-origin opener policy header, COOP. And what this does is it tells the browser whether other windows can hold a reference to your window, and it's well supported across browsers. So its default value, however unsafe known, is insecure. So set a value of same origin, and this makes sure that no cross-origin document is going to get a reference to your window. But still, there are reasons why you may need your site to communicate with cross-origin windows, for example, for an authentication flow. So in this case, you can use the value of same origin allow pop-ups. And with that, a pop-up that you open can get a handle to your window. So now maybe you're thinking, wait, if I change what windows can hold reference to mine, won't this break things? Well, it may. So it would be nice for you to be able to see what could break without actually breaking things, right? Well, there's a way to adjust that with that header. You can use the cross-origin opener policy report only header. And you would configure it in the same way you would have configured your cross-origin opener policy, plus you would add the report to directive and specify an endpoint. And you would deploy that, and what will happen then is you will receive reports to that endpoint, to that URL, in case anything gets blocked because of that policy, because of your cross-origin opener policy. But since it's report only, things won't actually break for your end users. So you can adapt and fix what needs to be fixed, and once you're not receiving reports anymore, it means that your policy can be safely deployed in enforcement mode, that is without the report only bit. So that was for Windows, but still as part of our to-do number 2, we want to look at how we can isolate frames. What you can do here is, in order to prevent your documents from being embedded as iframes, is use the Xframe options response header. And this is supported across browsers. So today, the default value for that is allow all, which is insecure because any origin can embed your web application with it. So what you want to do instead is to set it to same origin. And this is relatively simple change that's definitely a security win. And what this means is that with this, only your own origin can embed your own documents as iframes. What you can also do is, as iframes, what you can also do is to prevent all embeds altogether with the deny option. This is the most strict. Now, I know by now you're probably thinking, really, we have like COOP, Xframe options, you're really giving me more work. And well, you'd be right. So it would be great if the default value for these headers was already secure. And we're working towards that. The values I've just recommended for COOP and Xframe options may become the default values in the future. So you would still have a possibility to opt out and set the other values we've talked about. But with this, most applications would get more security by default. And only if your site needs a specific behavior, then you would need to do the work of opting out. So we're hoping to work with other browsers for alignment around these proposed defaults. We took a good look at what you can do today to protect your site. Now, the question is, what's next for Chrome and the web? So first, we've seen that site isolation does give you some protection, but it's not available everywhere. So one thing Chrome is doing today is to try and extend it wherever possible. And a few months ago, Chrome has announced that site isolation would be extended to extensions, and it would also be improved for Android users. But there's more to that. So Chrome plans on deploying further mitigations against Spectre by isolating websites not based on their origin, not based on the site, but based on their origins when the device's memory allows for it. There are a few roadblocks to that, though, and one of them is document domain. So on top of preventing origin isolation, document domain is also generally dangerous because what it does is it allows a page to relax the same origin policy, the fundamental rule of web security that we've talked about in the introduction. Because of that, we recommend that you do not use document.domain and instead use window.post message if you need to communicate between cross-origin documents without relaxing the same origin policy. So in general, for this reason, it's helpful to follow upcoming changes and deprecations. So that would be the to-do number 4 for you. Now, there are a few ways you can do that. A few things that can help. One thing is DevTools. In DevTools, there is a way for you to check out specific warnings, deprecation warnings, and you can also take a look at the Issues tab that highlights different issues in your code, including if you're using an API that will be deprecated in the future. So that's a good way. And other than that, you can also check the link I have just added to that slide to check for upcoming deprecations. And finally, what you can do is use the reporting API. What the reporting API does is it gives you a way to receive reports when something is going wrong with your site, either a policy you've set is being violated, or most importantly here in this context, when you're using an API that will be deprecated in the future. So check it out. That could be interesting. So taking a step back, what all these future changes have in common is one goal: make the web more secure by default. And hopefully this means less work for you. But until then, there are a few things you can do to make your site more secure. So let's summarize what we've seen. Here are your to-dos, what you can do today to make your site more secure. You can examine SecFetch headers in incoming requests and decide what requests you want to respond to. Complement this with cross-origin resource policy of same origin to protect your resources further. Limit access to your window with same origin cross-origin opener policy. And finally, lock down cross-origin embedding of your site in an iframe with xframe options, same origin. And finally, follow the upcoming changes. Now, keep in mind that this is just one reasonable secure config. You may need to adjust that depending on your own use cases or constraints for your site, either by relaxing that or by making this stricter. So if you apply these headers, it's already a big win for your site security. But I didn't cover everything. So if you want to see a full list of security measures you can take for post-Spectre web development, but also in general to isolate your web application, head over to this URL. And for a friendly reference guide of security headers, check out this guide. This gives you an overview of many security headers you can deploy in your application today to make it more secure. So make sure to have a look. And for the security researchers watching, when you're looking for vulnerabilities in sensitive web applications, you can check if the headers we've talked about are present. And another thing you can do is to try out the Spectre demo and help improve it if this is something you're excited about. Right. Thanks for watching. You can find me on Twitter at modnals, and for developers news and guidance about Chrome, you can follow Chrome Dev. See you.